In this lesson, we're going to talk about projectile motion, or otherwise known as vertical motion. So a couple things to know before we begin. The formula. This is the formula for projectile motion that we're going to be using. And the most important part to really focus our attention on is that it's not to be confusing, but in this section, our x's and y's of our quadratic are going to turn into t's and h's. So our h is going to be, our x is going to be represented now by the letter t, which will represent time. And then our y is going to turn into our h, which is going to represent height. Because the basics of projectile motion, if you think about it, what we're going to be doing is we're going to have a starting point and we're going to be launching an object into the air in a parabolic form, and it's going to be landing in some specific location. So what we're going to be talking about is going to be our time, which is our x-axis, and we're going to be talking about our height, which is our y-axis. So instead of using those variables x and y, we're going to be kind of transferring them over into t and h, but they still do mean the same exact thing. All right, let's talk about this formula. So it says h of t. Well, h of t is going to be the object's final height. So wherever the object lands, that's going to be our h of t. Then it's going to go to the other side of the equation. It's going to equal -16. -16 is a special number. It's a number derived from gravity on Earth, which is a constant number. When you get to a physics class in high school, you'll probably end up in a class where you end up deriving this using some type of experiment of some sort. But one thing to know is that -16 is always going to be a negative number, which means that the parabola is going to be opening downward, just like my picture up above. It also tells us that you'll always have a maximum point, just like we talked in that first section on graphing. Okay, continuing on with the formula. The t, both of the t's actually in our formula are going to represent time, like we talked about. And then we have this letter v. V is for velocity. Velocity is a measure of how fast something moves in a particular direction. We could say something like the velocity is a speed with the direction. So for right now, we just need to be able to acknowledge that we have a velocity number and be able to plug it into the appropriate location of the formula. Okay, and the last variable we have here is the s. The s represents the initial height of the object. So wherever the object begins is going to be our s. Okay, we're going to go ahead and solve a variety of problems. I think I have 4 for you here. And we're just going to talk about this vertical motion. All right, here's our first one. The life application here is just throwing a ball into the air. So it says a ball is thrown directly upward at 64 feet per second from a platform 80 feet high. Okay, so a couple things we need to know here. We need to know what numbers are going to go into our equation. So let's go ahead and try to generate our equation before we even try to answer any of the questions. So our h of t is going to be the final location, right? So do we have a final location here? Not necessarily. So I'm just going to leave that as h of t. Sometimes you'll have a number there and sometimes you won't. I'll explain that. You'll see as the problem unfolds why that is how it is. Okay, I'm going to write my constant due to gravity. And I'm not given any time here. So I'm going to go ahead and leave my time squared. It's just like the x squared in a regular quadratic equation. It actually is there. You don't fill it in. Okay, my velocity now. This is where I actually start putting some numbers in. So my upward velocity is 64 feet per second. So I'm going to say plus 64 with a t. And then I'm going to add my initial height, my s. So it says that it's starting from a platform that's 80 feet high. So my initial height is going to be 80 feet. All right, so that's the equation that I'm going to be using to answer these questions. Question 1 says, what will be the object's maximum height? Well, we know that using a parabola, if I just draw myself a little sketch here, so I can just draw myself a little sketch saying that the ball is initially being tossed off of a platform that's 80 feet high. Okay, and I'm just going to go and I'm going to assume it hits the ground. There's a nice parabolic form. What the problem is asking me is, what will be the object's maximum height? How high is it going to be off of the ground? That's what we want to find out. So we can see that this maximum height point is the vertex of the parabola. So if we remember back in the first section of this unit, we talked about the vertex. So I'm going to go ahead and calculate the vertex. The vertex, you begin calculating it by using that formula, x equals negative b over 2a. That's our axis of symmetry formula, right? That is going to give me the x-coordinate of my vertex. So let's go ahead and solve it. X is equal to negative b, which is negative 64, divided by 2 times negative 16. And I'm just going to go ahead and solve that out. So I'm going to say negative 64 divided by negative 32. All right, simplify that down, 2. So my x-coordinate is going to be 2. Now don't get confused with the variables. Again, x is the same as t. So if you really wanted to, you could say that our t is equal to 2. That'll be just fine. All right, but that's not what we want. We want the height. Remember from the last slide that t is in our x position and h is in our y position. So to determine the y value, we're going to take that t and substitute it into the problem. So let's go ahead and do that. H of t is equal to negative 16. I'm going to go ahead and pop them in there. 2 squared plus 64 times 2 plus 80. And what I'm going to do now is just all calculator work. Plug everything into your calculator and go ahead and crank that out. All right, I get that h of t is equal to 144. Now, 144 what? 144 feet. This is how high the object is going. So technically, I could say that my vertex is my maximum height, which is going to be, after 2 seconds, it will reach 140 feet. I'm sorry, 144 feet high. That is going to be my maximum height. So it kind of answers number 2 for us. When will it attain that height? Well, it's going to attain that maximum height of 144 feet at 2 seconds. It's not going to take very long. And we're done. So this is the type of problem that you're trying to figure out the maximum height. Let's try another one. All right, the life application is the United States Navy. A Navy ship is in distress and launches a flare from sea level with an initial velocity of 190 feet per second. When will the flare hit the water after exploding in the sky? All right, so you can see that the question has changed here. The question is now, when will the flare hit the water? So we want to know time this time. We don't want to know height. It's not asking us for the maximum height of the flare. So before we begin, let's go ahead and generate our equation. So h of t, do we have a location where it landed? Well, we do. Do you notice how it says hit the water? That means that it's going to be represented by a 0. Our h of t is now going to be a number, 0. I'm going to now add my constant due to gravity and my t squared. And I'm going to add my velocity, which is 190 feet per second, t. And then I'm going to add my initial height, which you can see here that I'm not given an initial height. So my initial height is 0. So I'm actually not even going to write plus 0 there. It doesn't make sense. So this is going to be my quadratic that I'm going to use. So let's go ahead and solve this. This time, like I said, my question is different. It's asking me, when will the flare hit the water? Okay, well, we're looking for the t now. So now we're trying to solve for this t and this t. And luckily, last unit, we learned how to solve a quadratic by factoring and by taking the square root of both sides. So this time, I'm going to go ahead and I'm going to factor it. And there's nothing different. I'm going to factor it just like I have been. So it looks like my factors for this one are going to be, I'm going to go ahead and write 0. And then I'm going to go ahead and I'm going to factor out a -2. I always like to factor out the negative, just like we did in Unit 9. That's going to leave me with 8. Oh, I'm sorry, -2t. Let me go ahead and erase that. I meant to say -2t. Okay, so -2 with a t. And I'm going to be left with 8t plus 95, it looks like. Okay, great. All right, at this point, I'm going to use that technique where I have my 2 apparent factors. Here they are. And I'm going to use my 0 product property. And I'm going to go ahead and set them both equal to 0. So -2t is equal to 0. So if I divide both sides by -2, that gives me t equals 0. And then if I take my 8t plus 95 is equal to 0, I'm going to go ahead and subtract that. So I have 8t is equal to -95. And let's see, -95 divided by 8, that's going to give me t is equal to, what is it? Now, I got an answer as negative 11.88, and you're probably thinking, well, that's wrong. That you can't have negative seconds, right? Well, I just looked back up in my problem, and I actually made a minor error. You probably saw it. So right here, when I factored out the negative, I left it as a positive. This is supposed to be a negative here. So let me go ahead and let me go back and fix that. You probably already saw that. It doesn't really change a lot to our problem other than that negative part. So let me go fix it and I'll show you the difference. So I'm going to go ahead and put that negative there because if I factor out that negative, negative times the negative gives a positive. So here we go. 0 product property one more time. Sorry about that. I'm just going to add 95. This time. There we go. So 8t is equal to 95. That's much better. Divide by 8. That gives me an answer of 11.88. So you can see here that I have 2 answers, right? But which one is correct? The question being asked is, when will the flare hit the water after exploding in the water? Is it possible for it to be when the time is 0 seconds? That doesn't even make sense. So it has to be our second answer choice, 11.88 seconds, which isn't very long. So you can see the difference between this problem and the last problem. One was asking for the maximum height, and this one was asking for the time. Let's go ahead and look at 2 more problems. All right, let's take a look at this one. This one, the life application, is a baseball game. So you hit a baseball straight up in the air. And the baseball is hit with an initial velocity of 80 feet per second, and the bat makes contact with the ball 3 feet off of the ground. We want to know, after how many seconds does the ball reach a height of 99 feet? So let's go ahead and just kind of generate our formula with all this information. The first thing is going to be h of t. H of t is going to be where the ball lands, or where is the location where we are trying to determine the answer from. Now this one's kind of tricky because if you look at our question here, it says, after how many seconds does the ball reach a height of 99 feet? That is our ending location. That is our h of t. So I'm going to write in 99 as my h of t. Then I'm going to write my constant due to gravity. The question's asking me how many seconds, so just like in a regular quadratic, I'm going to leave it as t squared, plus my velocity, 80t, plus my initial height. And you can see that the ball made contact with the bat at 3 feet off of the ground. So I'm going to say that my initial height is 3 feet. Okay. Here is where we begin the problem. The goal here is to find out after how many seconds does the ball reach a height of 99 feet. How many seconds? We're solving for t. We are not solving for the maximum height, although we could if we'd like. We are trying to figure out this. I'm going to draw a nice little picture here. So we have a little podium, and it's about 3 feet tall. And we have a nice parabola going up in the air. The ball's going up, and it's going to hit the ground. We want to know, when will it hit that 99 feet? So let's just say that 99 feet is somewhere about right here. But as the ball goes up in the air and hits 99 feet, and then it goes up further, doesn't it come back down and actually hit another location that is 99 feet? So there's actually going to be two locations, which means we're going to have two answers. So let's go ahead and solve this by factoring. To factor, we always have to have our 0 on one side. So I'm going to begin this problem by subtracting 99 from both sides. And I would do that in any situation where I have to solve a quadratic. Alrighty. So I have 0 is equal to negative 16t squared plus 80t minus 96. Alrighty. At this point, we need to do some factoring. So I probably want to think about this for a second and try to figure out what I can pull out. So go ahead and take a second to figure out your GCF. Well, that wasn't very hard because all of those numbers are divisible by 16. So I'm going to go ahead and factor out negative 16 as my GCF. This time I can't pull out a t, so be very careful here. All right, I'm going to be left with t squared. Now this time I'm going to be really careful with my symbols. So when I pull out the 80 divided by that negative 16 is going to give me that negative 5t. And whenever I take negative 16 out of 96, that's going to give me positive 6. So I just factored it out. That's all I did. Now you can see that it generated this nice perfect square, not perfect square trinomial, a trinomial with a coefficient of 1. So let's go ahead and factor it. 0 equals negative 16, and I'm going to factor this into two binomials. Again, what I'm trying to do here is I'm trying to find two numbers that multiplied to give me 6 and that add up to give me negative 5. So you might be thinking negative 3 and negative 2, since those work out. So I'm going to say t minus 3, and then I'm going to say t minus 2. Okay, at this point, now that we're factored, I'm going to go ahead and find my factors. Now, negative 16 is a factor of this quadratic, but it doesn't have a variable next to it, so I can't set it equal to 0 using that 0 product property. So I'm actually not even going to use that negative 16. I am going to use my t minus 3, and I'm going to end up using my t minus 2. So if I use that property, I'm going to go ahead and add 3 to both sides. T is going to equal to 3. And then on the other side, t minus 2 is equal to 0. I'm going to add 2 to both sides. T is equal to 2. So you can see, again, I have those two answers. But here's where the two answers come into play. At 2 seconds, you can see that it's going to reach that first 99 feet. Again, this is 99 feet above the ground. But then it's going to be 3 seconds for it to reach the second 99 feet. So depending on the question, this particular question just asks us in general, how many seconds will it take? Well, it'll take 2 seconds to reach the first height, and it'll take 3 seconds to reach the second height of 99 feet. Sometimes you might have a situation where it asks you, when will it reach 99 feet on its way back down from hitting its maximum location. And you'll be able to say, well, that's obviously going to be 3 seconds. So just pay very careful attention to the type of question that's being asked. Okay, I have one more, and this is actually my favorite question. All right, the life application here is just a rocket design. So Mr. Bolt, he has a tech ed class, and they build model rockets. When they test launched their rockets outside, a rocket landed in a nearby tree, 30 feet above the ground. If the launch pad was 2 feet above the ground and the initial velocity of the rocket was 64 feet per second, how long was the rocket in flight before it landed in the tree? So just kind of a little picture of what's actually happening here. You can see that we have a tiny little launch pad over here of 2 feet. And we have a rocket that is going to go in a parabolic form, and it's going to continue until it gets stuck in this beautiful oak tree outside the school. And this oak tree just happens to be 30 feet above the ground. So that's kind of what we're looking at here as a picture. It's always really helpful to draw a picture. All right, let's go ahead and see if we can generate our equation. All right, so h of t. we want to know where did it land? Well, we know that it landed 30 feet in the air. So I'm going to go ahead and write 30 as my h of t. And then I'm going to go ahead and write my negative 16 t squared plus my velocity, which is 64 with a t. And then my initial height was the height of my podium, which was 2 feet. Okay, so now that we're all set up here, let's go ahead and we're trying to figure out how long was the rocket in flight before it landed in the tree. So how long indicates that we're looking for the variable t. We are not looking for the maximum height in this situation. If we were, we would be looking for the vertex. Okay, so right now we're just looking for the t. So that means that we have to factor. Let's go ahead and take our quadratic and let's get 0 on one side. Okay, at this point, we're going to continue factoring. This time it's going to, you really have to think about the factoring technique. So go ahead and pause the video and go ahead and see if you can start off factoring this trinomial. Okay, let's go ahead and factor here. 0 is equal to, I think that I'm going to pull out a negative 4. So I'm going to go ahead and pull out a negative 4 here. That means I'll be left with 4t squared minus 16t, and then I'm going to do plus 7. Okay, there I have my trinomial, but you'll see that my new trinomial here now has a coefficient that's greater than 1. So I actually have to do some work now. So let's think about it. Here is my x, and I'm looking for 4 times 7, so 2 numbers that multiply to give me 28. And then I'm looking for that middle number, 2 numbers that add up to give me negative 16. Alrighty. All right, I came up with these two factors. I said that it was negative 2 and negative 14. Hopefully you came up with those same ones. So now let's go ahead and factor this just like we did in Unit 9. 0 is equal to, keep your GCF out there. And now I'm going to break down 4t squared. And I'm going to go ahead and prefer to write in minus 2t first. And then I'm going to subtract 14t. And I'm going to add 7. And all I did was I took that negative 16t and I broke it down into those two pieces. Now I'm going to go ahead and break down these groups and I'm going to group it. So 0 equals negative 4. This is where I start my brackets. I'm going to pull out 2t. I'm going to be left with 2t minus 1. And then over here, just like in our factoring unit, remember, we still want to end up with 2t minus 1 here. So in order to do that, I'm going to have to pull out a negative 7. All right, now I have my factors. So I have 0 is equal to negative 4. And then I have 2t minus 7. And I have 2t minus 1. Okay, now I want to use my zero product property rule. So I can see that I have this negative 4 again without a variable, so I'm not going to use that. So I'm going to start off by using these two factors. So I'm actually going to bring my work up here. So now I have 2t minus 7 is equal to 0. I'm going to go ahead and solve that out. Divide by 2. Now, you could say that t is equal to 7 over 2, or you can actually write in the decimal there of 3.5. And I'm going to use 3.5 because we're talking about seconds. And then my other one is going to be 2t minus 1 is equal to 0. So let's go ahead and solve that. So our t will end up being 0.5. Alrighty, so there are my answers. Now the question is, well, which one is correct? Because I have 2. Well, again, just like the previous problem, we have 2 locations where it reaches 30. The first one is going to be the other side. So this is going to be the one that doesn't take as long. This is going to be that t is equal to 0.5 seconds. The second one, where it comes down and it lands in a tree, and the word lands is a big giveaway because it's landing, it's coming down from the parabola. That's going to be when t is equal to 3.5 seconds. So technically the answer to this particular question, how long was the rocket in flight before it landed in the tree, is going to be t is equal to 3.5 seconds. So the big takeaways from projectile motion are two things: finding the maximum height of an object in the air, and then finding the time that it takes for an object to get to a specific location in the air or on the ground. All right, so those are all the examples we have for projectile motion.